Right, let's get started. So, again, this morning exercise, you see how many people have the prerequisites met for this particular training program. Okay, most of you are struggling to find out how the code works. Anyways, let's see. The training agenda for this two-day program will be mostly on these topics. We'll be learning about classes and objects, errors and exception handling, advanced OOP features, and OOP considerations, garbage collection, memory management. Everything that you need to know about object-oriented programming, the Python way, right? Tomorrow we'll be learning about some interesting things like decorators and AOP. We can talk about annotations, how to use decorator patterns, aspect-oriented programming patterns in Python. Some interesting design patterns which are used in Python, okay, very commonly used. Also, we learn about creating generators, iterators, coroutines, and also compilation expressions and common design patterns in Python. And time permits also talk about how do you create reusable library packages in Python. This is the overall agenda for 2 days, right? So, before we continue, I think this training will be a little fast track because 2 days is too short to cover the complete breadth. So, I'll keep it as fast as possible. I will strategically give you hands-on exercises during the break times. That's how I will do. Most of the times, you'll see me typing, so you can practice as and when I demonstrate. If you have any questions, doubts, feel free to ask me as and when they arise. Don't ask me what's a while loop, what's a for loop, what is star hours, what is star keyword hours. You're expected to know that before attending this training, right? Anyways, so and also I have set up a clipboard, global clipboard. You can type this in your browser, keep it open. So every time I have some code samples which I type, long code samples, for a tryout, I'll copy paste that into this clipboard. So you can copy from there into your editor environment and try it out. Okay? You can just type this particular path. Try not to look empty. Okay? Are you able to make a note of this path? Is one? Okay, smart. Or I'd like to have a quick introduction of yourself. Tell me your name, destination, and how comfortable you are with Python. If you've been using Python, elaborate on its usage, and also which other programming language background you're comfortable with. And more importantly, I want to know whether you have an object-oriented programming knowledge in any language. Can you elaborate that? If you are new to OOPS, can you right? So an expectation on training programs. Okay, that's fine.
Tulsi.
Right.
I'm currently working on Java and Python.
Okay.
And my experience is 9 years.
Okay.
And on Python, I'm coding, but I'm not that much. But I know the concepts all the time, but not in that time.
Okay. Okay. Okay.
And I know the concepts of mixing.
All right. So what's your expectation on training?
So just want to know on the deep inside Python.
Python deep inside the object-oriented programming. You attended earlier training of mine?
Yes.
Beyond basics, is it?
Yes.
No? Okay.
Not beyond, some basic time. I'm not sure what the name is.
Okay. Okay. Correct. Yeah. Is it?
Yeah, I'm Fazil. So I'm working as a software engineer. Experience, I have around 15 years of experience. Working on Java J2 full stack.
Okay.
So the reason for this training is we have one machine learning project.
Okay.
So want to switch to Python.
Okay.
But I don't have any basics, so very challenging for me.
All right. Okay. I've attended the basics for 10 years. All right. Yes.
I'm Leo Rahan. So part of platform QA
Okay.
for reusers server.
Okay.
So far 12 years of experience.
Okay.
Learning Python, we have to convert the messages so learning Python.
Okay. So how comfortable with object-oriented programming concepts as such?
Still Python is learning.
Okay. Right.
My name is Tejinder, software engineer in SP MSc routing,
Okay.
and 7 years of experience.
Okay.
And Python, I'm a beginner in Python. I have basics.
Okay.
I know object-oriented programming also.
Which language?
I know C, Java.
Okay. All right. So what's your expectation for this training?
Expectation of being a deep.
Understanding about object-oriented programming, which is okay. All right. Yes. Hi.
I'm working in Java, 9 years experience.
Okay.
So I'm learning Python now.
Okay.
I attended two of your sessions previously.
Okay.
But that,
All right, so I'm just trying to make it a complete stack. Okay, all right. So what's your expectation from this training? You're looking for getting some good understanding of object-oriented programming. You have some idea about object-oriented programming. Okay.
I
Java?
want to learn Python.
Okay, all right. Yes. Right.
Hi, myself Alok. I have around 11 years of experience. I mostly work on C. Python I'm very basic.
Okay,
I am attending this to, I know object-oriented in C++ concept, but still I'm not using it because
okay,
mostly system side, so we are
Alright.
using C only.
okay,
I'm attending this Python training because my expectation is, one of your training you said you have to unlearn C++ concept to learn Python.
okay. So come to unlearn that.
So what's the difference between OOP in Python?
That's a C++. Okay, all right. Interesting. Yes, yes, sir.
Some basic knowledge of the
Okay. Okay.
Oops,
New to something.
Which other language you're comfortable with?
I worked on C.
C. Okay. C. Okay. So new to something.
Myself, Krishna Desan. I'm working as a software engineer in iOS X PNG.
Okay.
I'm working on PyATS scripts.
Alright.
My expectation regarding this is a deep understanding, like how to good understanding regarding the oops.
Concepts.
I have basic understanding of Python
Okay.
and I have basic understanding of C++ oops concept.
Okay. So you want to see how it works in Python.
Hey, my name is Paul. I am from automation team. I'm using Python for automation.
Okay.
I have 2.5 years experience. I'm quite comfortable with Python, like the basics of Python. I am comfortable with C also. And OOPS is like C++. The expectation from this training is that to get a better understanding of the OOPS concepts as well as how do we implement OOPS with Python. My name is Hari. I'm basically hardware engineer.
Okay.
Basically, I have experience with OOPS languages,
Okay.
but I'm very started for Python programming.
Okay.
Yeah, and just I wanted to start
Get a holistic picture of how the object-oriented concepts work in Python.
with
Which language you're comfortable with the object-oriented programming as such?
C++.
C++. Okay. Right. Your introduction. This is walked in.
Gautam.
Hi.
I work in CSG BU in Cisco.
Okay.
I am also familiar with OOPS in Java,
Java. Okay.
but for the past 1 month I'm working on Python, so I got
Okay. So what are you working on Python? Automation or is it?
development.
Okay. Okay. All right. Interesting. Okay. I'm looking at all of your wavelength. A little bit of mixed batches or mixed wavelength here. Never mind. So, anyways, about myself, the best way to know about me is going to my website www.chandrasekhar.info. I'm a polyglot, so I worked on various programming languages, Java, plus Scala, Clojure. I used to work on C++. Today, my C++ skills are pretty much rusted. It's been almost more than 10 years since I touched C++. So I learned a C program in C++. But once I learned Java, I forgot half of C++. Once I went neck deep in Python, even rest of C++ I forgot. Okay, but I know the object-oriented concepts in many languages. So this is my skills. So I've been working on Python since '99, when Python 1.5 was pretty popular at that time. But it's not a fully object-oriented language at that point in time. Python 2 was a full object-oriented programming language, of course. So, and about myself. Anyways, let's get started with the OOP preliminaries. So even before we jump into object-oriented programming in Python, let's try to make sure that the fundamentals are straight. Some of you are new to object-oriented programming, is to make sure that they fall in the same wavelength of others, right? So why develop a program using object-oriented programming? Why do you use OOPs? What is OOP all about? And what benefit that OOP provides in relation to procedural or imperative programming? Anybody? Why should I develop my program using object-oriented programs? Why should I use OOP in the first place?
Optimized.
Yeah?
Optimized.
Oh, OOP does not optimize. It makes your code bloated.
But it represents real world objects.
Why do you need real-world objects? Why do you need to worry about real-world objects? When you write programs,
Programming will be easy.
the real world is a commonly used buzzword, that's not really clear.
Okay.
Suppose I have a problem statement given to you. Maybe a web application must be developed for some e-commerce something. You have a choice to develop that entire e-commerce application completely using procedural paradigm, functional programming paradigm or object-oriented programming paradigm, what circumstances would you choose object-oriented programming in relation to other paradigms?
Data is sensitive or something.
Yeah?
Data.
Data is about?
Sensitivity or something.
No, I think I didn't get what you said. Data is?
Like when we are like more concerned about the data,
Are you telling me that procedural programming doesn't worry about data? Structures. Data structures, right?
If we can model the solutions in the way that the program is also in same way in type objects.
Is there anything that can be done in OOPS which cannot be done in procedural way? Is there any problem that requires purely object-oriented way to solve it, but cannot be done using procedural way?
Concurrent.
Graphics.
Now, concurrency is nothing to do with OOPS. Yeah?
Graphics.
Experimental system is written in C. Remember experimental system, right? Powering your...
Procedural always
It's purely C.
sequence.
So you're talking about graphics, C. OpenGL library is C library. Right? Yes.
A procedural always will be in sequence. So object oriented without sequence we can do.
No, it's nothing to do with that. Nothing to do with concurrency. Object orientation nothing to deal with concurrency. Concurrent programming is a different practice altogether. It's a design pattern. You can do concurrent programming even using procedural paradigm. Yes.
OOPS makes reusability of the code easier.
So procedural programming. Why do you use procedural programming? For reusability, right? If you're looking at reusability and modularity, procedural programming fits the bill. The purpose of procedural programming is what? You break your program into a set of functions or procedures that can be called over and over again. Reusability. You put a bunch of functions in a library, right? In a package. It's a modularity. So we're talking about modularity or reusability. I think you should stick to procedural programming. So yes, OOPS does provide modularity, reusability, but there's something else beyond procedural programming that OOPS brings on the table. So what is it?
Using OOPS, I can design, say, if you take this order I can design in a better way compared to procedural language. Using OOPS, I can create the
But
order.
better is very subjective. Very subjective. What you think is better might not be better. There's a funny paradox about OOPS. Not sure if you heard about it. If I say I want a banana, with object-oriented program, you don't just get a banana, you'll also get a gorilla holding the banana and the complete jungle alongside with it. That's a joke about object-oriented programming. All I want is banana, but you can't just have banana hanging in the air. Where does it come from? Somebody's holding it. And where does he belong? Somewhere else. And you will be related to that particular gorilla because you might be in some part of the jungle, reachable to the gorilla. That's how it is. Anyways, coming back to the concept. Actually, object-oriented programming makes things more complicated. You accept that fact? Let me tell you one fact. When you learned programming in academics, learning procedural paradigm is not too difficult. Maybe most of you started programming in C, bad luck. You'll struggle with pointers in the beginning. Forget about the pointers and the low level stuff the C brings on the table. But if you look at logical thinking, like finding a Fibonacci sequence, generating a Fibonacci sequence, finding out a number is prime, very basic arithmetic algorithms, you can very well code in C. Am I right? So it is very like mathematical, right? It's very much like mathematical. So you can say y is equal to f of x. The moment you were introduced to object-oriented programming in academics, you had all this kludge of encapsulation, abstraction, polymorphism, inheritance, all jargons, all the way around. And you have a lot of cryptic syntax to support it. So most of us had a very steeper learning curve to model what you call as real-world objects. When we are solving a problem in computers, we don't really care about real world, do we? We just want a problem to be solved. Why do we care about real world like objects? Well, one of the important benefits that OOP brings on the table, apart from modularity and reusability, is the important one, delegation of concerns. What exactly is delegation of concerns? If at all I am trying to take a problem statement, solve it using procedural way, it is very similar to cooking recipes. That's a classic example I give. Suppose you want to cook something. You want to learn how to cook some dish. What do? You will look up a cooking recipe, the recipe book. The cooking recipe is procedural in nature, in real world. You know why? Because you can see ingredients as data. Then you have procedure 1, boil water. Procedure 2, chop so-and-so ingredients. Procedure 3, stir ingredients in water. You see that procedure, right? You know how to boil water for one recipe, you will be able to do it for any recipe. Reusability in place. So procedural programming is designed with an intent that the person who's trying to solve a problem is just one person. One person. It's very important. there's an infamous quote, that too many cooks spoil the soup. You know why? Procedural paradigm. Suppose if there are 3 cooks cooking one single dish, what's the problem there? One single dish, they should know what each others are doing. One cook should know this cook has added salt, so I should not add it. So they should communicate. More the number of cooks, more problematic it becomes. How is it being solved using procedural paradigm today? We have something called a master chef. We see in hotels, right? We have a master chef who does micromanagement. He will tell one cook, do this, don't do anything else. Do this, don't do anything else. Do this, don't do anything else. He will micromanage each of the members. He will get the results and integrate it. Finally, he will taste it and see whether it tastes good. So it requires a lot of effort to coordinate a team of people trying to solve a problem. It's not the problem at hand that's the issue. It's the team who is trying to solve the problem that's an issue. If you use procedural paradigm and work as a team, right? Each team member should know about every other member's functions. What function is called, what argument should I pass, what is the expected result, and so on. There's no way to hide or make things more simpler, right? Object-oriented programming just provides an architectural pattern to simplify the view to a problem statement. This modeling of object is what? Is basically unnecessary details are hidden inside the object, only the necessary interface made available. Take an example of real-world objects. Why do we say object-oriented programming is all about real-world objects? Take an example as marker. I know how to use a marker. To use this marker, all I care about is open, write, close. I don't have to be a chemical engineer. I don't have to worry about what this marker is made up of. I don't have to be any kind of engineer to know how this marker is manufactured. I don't care about how it works inside. All I care about is the interface given to me. It is open, write, close. Right? This is the beauty of real-world objects. We know how to work with a pen, we'll be able to work with a marker. That's what real-world object orientation means. So if you look at object-oriented programming in real world, a classic example could be assembly line units. Let's say manufacturing. So let's say car manufacturer. Do you think car manufacturers today manufacture tires? No, they don't. I don't think so. At least in India, they don't. You can see, let's assume you have a manufacturer like Maruti who's manufacturing cars. The tires are not manufactured by him, it's coming from Opel, Goodyear. Maruti doesn't care how a tire is manufactured. They only care about the specifications. Does it fit into the car as per specs? Right? They don't care about how a battery is manufactured. Somebody else is specializing in manufacturing battery, whether it's Amaron or Exide or somebody. Right? Somebody manufactures auto electricals. They just assemble them, suiting their needs. Right? This is what we call as delegation of concerns. So each team member is going to be delegated to work on only one particular module. The module could be an object, yes.
The same thing we can see in procedure language. Like if I'm writing a Python script, I can import some of the module.
Yes.
And then I can use the function in the module. I'm not concerned like how the module is implemented.
The problem here is that, you can do delegation of concerns purely using procedural paradigm. Problem here is that you want a module. When a module is given to you, you want only 4 functions in it. But a module exposes to you about 100 functions, it looks overwhelming. You know what I'm trying to say about? Or say, for example, let's assume if I'm going to operate a TV, all I care about is the power on, volume up, volume down channel. But if I have a TV equipment like it lived in 100 years ago, when TV was first invented, it had a lot of controls, too many controls. Too many controls means it overwhelms the user. It requires more amount of knowledge to understand how to use it. Early days TV, I'm not sure if you use the old black and white TVs, you are just tuning, right? Today we don't do any tuning. Early days you need to tune it. You need to worry about tuning, otherwise you'll have the wavy picture and all that. Today everything's automatic. People like simplicity of interface. Procedural programming exposes everything to you. What you don't know what is useful, what is not useful. Understanding what I'm trying to say? For example, the manufacturer's marker can change the ink, the composition of the ink, and I don't really care. That's encapsulation. How the ink is manufactured, what composition ink has today is using some composition. Realizes it's a little toxic. He might come out with a better composition tomorrow. The way I use the marker is not going to change. It's going to be the same. Understand what I'm saying? With procedural paradigm, even when you don't want it, unnecessary details are made available to you. Getting? So object-oriented programming tries to make delegation of concerns better. I'll not say delegation of concerns not possible using procedure. It is possible. But we should discipline ourselves. Programmer A should tell programmer B, only touch these functions. Don't touch other functions. You tell him that communication is required. The object programming, you don't have to communicate, only expose 4 functions. Other functions don't expose it. Private methods, you don't know about it. Private interfaces, private members, right? You don't expose whatever methods you feel is unnecessary for others to use your object. Understand what I'm saying? So that's one of the interesting things that object-oriented brings on the table, right? So it makes delegation of concerns easier. Okay, remember, I'm not trying to say that to write an object-oriented program, you have to do it in C. You can write a perfect object-oriented program even in C. Or any procedural language. Any procedural language which allows reference to functions and some kind of data structure, right? You can write object-oriented program. In early days, your C++ compiler used to compile your C++ code to C code. When it's a class name and put some members inside a class, it ultimately becomes a structure in C with function pointers. And the private members will be name manualed. That's what happens. Today, C++ compiler generates the C code and generates the assembler code also. It is all transparent. So I told you that large projects that involve more programmers working together benefit by having to deal with lesser complexity when OOP is employed. That's the interesting part. See, as coming back to the problem statement, if I'm the only person who's going to solve a problem, and I care about every single intricate aspects of the solution, then I don't need object-oriented programming. I can do it a procedural way. If I'm willing to know about every intricate details about how my solution is going to be wired, I don't need object-oriented programming. Let me give you some real-world examples. We look at most of the popular open source projects, Linux kernel, written in C, not object-oriented. Why? Linus Torvald and his team, the high-level members, know about every intricate components of C, of that particular kernel. They do micromanagement. They sort of micromanage. Apache web server that powers more than 60% of internet, written in C. Brian Behlendorf and team, they know about every intricate component of that as Apache web server, not done in C++. But when you work on enterprise development, companies especially, you have benefit of OOP. Why? Because in companies, we don't have passionate programmers. In other words, a passionate programmer will stick to one project for his lifetime. That'll never happen in company. Passionate programmers are disposable. They're disposed of. Today, you work in one project. Once that project reaches some maturity, the project becomes mature, you move to another project, another challenging project. Somebody has to take over your project. And somebody who's taking over your project should not worry about all the complexity. Should have a simpler interface to work with it. This way, the success of object-oriented programming is all about, right? Clear. Coming back, if you look at procedural programming, we can say a program is broken to a set of procedures or functions. Function calling each other, right? Passing in data, getting data, and so on. In object-oriented programs, we say a program is made up of objects interacting or relating to each other. So one object will be related or interacting with another object. So when you talk about interactivity or relation, there are 3 fundamental relations that objects have with each other. What are they? Let's say 2 objects are there in a program and they have to be related to each other or they have to work with each other. There are 3 ways they can work or relate to each other. What are they? Yes? We call them as 3 pillars of OOP. Simple English words. What are they? Fundamentals, OOP, fundamentals. I'm sure you heard about this. We call them as is-a, has-a, user-set. Let me explain what this is all about. Right? Is-a relationship. I can say a marker is a pen. Is-a. You know what I mean by that? That means if I know how to work with a pen, I can work with a marker. This emphasizes inheritance. The terminology for is-a relationship is inheritance. Why do you use inheritance? Why do you use inheritance? Why do you really care about inheritance? Yes?
Code reuse.
You should never design inheritance for reusability. Never. That's a common mistake that people do. Inheritance must not emphasize reusability in design. Reusability becomes the after effect. Inheritance design must always be for generalization. The emphasis must be generalization. What is generalization? It's all about how we work with objects. Today I learned with great difficulty car driving a petrol car. Now we know cars are slowly moving to electric. Electric cars are getting better, right? The technology has got a lot better, so electric cars are coming better. Technical electric cars don't require a steering wheel and the clutch and accelerator that we normally find in these geared cars, which you find with the fuel-driven cars. Tomorrow, an electric car manufacturer will come with a joystick, like 2 joysticks, sci-fi movies. Will I buy that car? No, I won't. You know why? I have to learn car driving again. The beauty is, even though the car engines are being replaced with motors, completely electricals, the interface is still the same, right? Still the same steering, in the right way, has the same feel. The gears and the accelerator and the clutch, so-called clutch, in the right places, maybe there's clutch-like support, right? So that whatever concepts you learned with one object is not going waste. Inheritance emphasis is all about that, generalization. Generalization is nothing but you know how to work with one object, you create an object that inherits it, you'll be able to work with that also. Whatever concepts you learned to know to work with one object, you can apply in all the object that inherits them, right? So the emphasis is generalization. Reusability comes as an after effect of it. The emphasis must be generalization in design. If you want to worry about reusability by design, you should worry with composition. What is composition? Has a relationship. Car has a battery. A UPS has a battery. You know what? A battery manufacturer manufactures a battery of one particular shape, which can be fit into a car, which can fit into a UPS. Right? Car has wires for auto electricals. Your house has the same wiring, right? More or less, you can use similar wires for both your house wiring as well as your automobile wiring. So you see reusability there. So you talk about composition, right? One object, one complex object is made up of smaller, reusable concrete objects, right? Which you can see. And you also talk about users relationship. This is where the heavy complexity of object comes into place. Abstraction, encapsulation. You know what is users all about? Person uses a marker. I'm a person, one object, marker is another object. For me to use a marker, I should have methods called write method. You know what that means? I should know how to write. Only if I know how to write, I can use this marker. If I don't know how to write, can I use this marker? No, I cannot. Technically, I don't know what to do with this. Maybe take this marker to a tribal, maybe tribal in 100 years back. Not today. Today's tribals can use the smartphones, right? Maybe talk about 100 years back. You take it to a tribal and give this marker. He doesn't know what to do with this. He does not know what this is. You just throw it away, maybe. A person knows how to use a marker because I know how to write. So it's a contract, right? It's a contract that's being set up between one object and another object. Because one object knows about invoking methods on another object, right? We talk about contract, protocol for objects to interact or communicate, right? For me to drive a car, I should know car driving. Car must be a drivable object. That must be a drivable object. I should know how to drive. So it's a contract between these two objects to work together, right? Coexist together. Users relationship has the highest usage. Highest usage. One object using another object is very common. Maybe I'm running a huge application and I want to log something. So there's a logger object. I'll say logger.log. Logger.log. You know, my application is interacting with logger object. It's users relationship. Right? User relationship. How the logger is implemented, I don't care. I only know the interface for log is log. Use a method called log. Right? Maybe log to a database, log to a remote server. That's not my concern. That's not my concern. Right? We talk about abstraction, encapsulation playing a vital role. Right? Clear. So all of these are the foundations of object-oriented programming that you know. Okay, there's nothing to do with Python. Any language you want to learn object-oriented programming, these are foundations you should be aware of. Coming back to Python, class and objects. I should tell you that. There are a couple of factoids I should tell you about Python. There are many languages which force you to develop a program the object-oriented. Modern languages like Java, C#. You can't create a program which is not object-oriented. Am I correct? You write a Java program, you start with class definition. You can't have a method outside a class. There's nothing called global variables. You can't have a function outside a class. It forces you to develop a program the object-oriented. The irony is the language is not 100% object-oriented. Right? Whereas Python, on the other hand, is the extreme reverse. Python is a 100% pure object-oriented programming language. Not like C++, not like Java. They force programmers to think object-oriented way, but the language is not object-oriented. But the language is object-oriented, but does not opinionate a program. It does not tell the programmer, you have to develop a class, you have to develop methods and so on. Yes?
What do you mean by languages are object-oriented?
If you say a language design is object-oriented, every intricate component of a language is made up of objects. In Java, that's not the case. For example, class is not an object. Namespaces or packages are not objects. Right? Primitive variables are never objects. Methods are not objects.
You mean in Python we don't have primitives?
There's absolutely no primitive data in Python. Anything and everything that you can label, that you can identify, is an object in Python. Anything and everything that you can identify with a label, with a name, is an object. If I create a function is an object. If I say a is equal to 10, 10 is a literal data. Using 10, an object is created. A is a label to that object. Right? All variables are labels to objects here.
Even in the Java same, right? You create int I equals something.
Then it's not an object. When I say int a is equal to 10, it's a primitive data.
Yeah, but similar, right? Here. How it different?
It's very different. Completely different. When I say int a is equal to 10, you're trying to tell Python compile time, allocate this much of memory beforehand in compile time. I'll store a value 10 there. You know about the sizes, right? 32-bit, 64-bit, right? You don't have such kind of sizes in Python. Integers are first class objects. Strings are first class objects. Float is first class object. Everything is an object here. I'll show you an example here right away. This is core Python, right? But just nevertheless, because most of you will skip that. When you self-learn Python, you learn it like Java or C++, then you'll end up writing inefficient Java C++ programs in Python. No Python the Python way, things are different. I'll show you an example right here. Here's an example that generates multiplication table the Python way. This is my Hello World program I have shown in core Python trainings. Generally, it asks for user input, enter a number, converts to integer, stores it, represent as num. For I in 1, 2, 3, 4, 5, 6, 7, 9, 10, num into y is num into y, right? I have a similar program written also not just in Python, I've written one in C just to show you the complexity, the scale of complexity. Written a similar program even in Java. I think it should start with a capital T somewhere. Hang on. I have to put it in. Yeah. Same program written in Java also. Just to demonstrate, I've compiled all these programs. The one compiled in C, right? Okay, I'll compile it again nevertheless. If I say 56, it generates multiplication table for 56. I hope it's correct. 56 into 10 is 560, right? You can see the C program, right? I'm declaring a variable of type int, right? So how big a value can it calculate? Suppose if I say run this table program and give a big number like this, will this work? It won't work. Any programmer will say, oh my god, this is beyond 32-bit or 64-bit. What should be the result? A robust language should fail right away. Robustness is never in the vocabulary of C programming. It only focuses on one thing, performance. Robustness, programmer's headache. Programmer should validate whether number is overflowing beyond the size and so on. Right here, the language will just say, I will fight with you. I gave a big number. He said, no, you gave me -1. Try running the same program in Java. I have compiled it already, so I'll just save time. This 56 ones are table, much like it in Java. Will this work? Will not work even in Java. I'll tell you why. Because in Java also, this is a primitive data. Same rule, 64-bit. But Java is a robust language. Proof, if it cannot solve a problem, it will complain right away. The language designed with robustness in mind, right? So that's one of the important traits of Java. That's one of the reasons why enterprise development prefers Java. I'll show you the Python program. Remember that 3-line program I showed you? Very few lines. Compare this, right? Lesser keywords, right? And run the same program, Python way. All right. What does it show? Numbers are limitless. You can type number as much that can fit into your system's memory. Python will not sweat. Your underlying operating system might. If it cannot allocate memory. Everything is an object here. Numbers are objects. So we can tell you that everything is an object in Python. It's a 100% pure object-oriented programming language. Though the language is object-oriented, it does not force the developer to think the object-oriented. See, if I'm writing a script of my own, it's only going to be maintained by me, a 10-line script, which will only be maintained by me. Object orientation is an overkill. I told you the paradox of object orientation, right? I just want a banana. I'll also get a gorilla and a jungle. I don't want that, right? Sometimes I want to just be specific to my problem statement. Scientists like that. Physicists, scientists, they don't like object orientation. Like to have simple functions to solve a problem. It caters to them. So it's perfectly possible to write a Python program which just says print hello world. No need to create a function called main. No need to create a class and put a public static void main inside it. None of those required. Even when you write a program in Python that says something like this, if I just say print of hello world, this program is 100% object oriented. You know why? Print is a label to a function object. This open close parenthesis is an operator. This operator is called as a call operator. Function objects are callable objects. Callable objects. So say call this particular object. They call this object, the object will have some kind of a body that will be executed. Function, right? Function body is executed. For a body to execute, it will take a reference to a string object that you pass as a literal. Every literal data are transformed to objects automatically in Python. Automatically. Think about it like if you relate to Java, string is anyway an object in Java. String literals are automatically boxed as string object. Think of integer, long, float, use them, right? In Java.lang, you will have that as classes. So every single data type in Python is a proper object. There are no primitive types in Python. Clear with this? Right? This is one of the important things, Let me tell you, in Python, everything is an object, including classes, modules, functions, and types themselves. You know what I mean? If I have to label something, you cannot label a non-object. You can only label objects. All variables are labels. All variables are like labels. Just like your objects around this room. I have some bunch of sticker labels. I'll stick labels on each of these objects. That label name which is there, right? That is a variable. On their own, the variables are useless. You cannot have a label that is not stuck anywhere. It has to stick to an object. You cannot have that means there are no declarations in Python. You don't declare variables ever. You know what is declaration? You create a variable but it points nowhere. That's what you see in statically typed languages. In Python, you define variables. You define objects. When you define an object, you label it. All of these are definitions. What are the definitions? I can tell you quickly. In summary, if I say A is equal to 10, right? This is a statement, assignment statement. The assignment statement contains the right hand side, left hand side. Am I correct? The right hand side is evaluated. The right hand side is an expression. The expression is evaluated. In this case, it's a literal data. But this literal data, by identifying what kind of literal data it is, it will create an object for it. If you see a little number like this, it will create an integer object which represents a value 10 in memory. It dynamically allocates 10 in memory. Technically, think of it like a C structure with the value 10 being allocated dynamically. And a variable A is like a pointer, it's like a label referring to this object. Referring to this object. So this is a reference. All variables are references. They don't store value. They refer to objects that hold the value. Remember this is very, very important that you know in Python. So all variables are references to objects. Even when I say B is equal to A, like this. When I say B is equal to A, what exactly happens? The right hand side is already a reference. If it's a reference, the reference is what is assigned to B, which means B happens to be one more label which points to the same object that holds the value 10. Now a nearby question. If I say B is equal to 20, after this, I will say print A, what will be the value of A? Yeah?
10.
How many say 20 here? Now be 20. So know one thing. Whenever you look at assignment, right hand side is evaluated. So B is equal to 20. Right hand side is what? Another object called 20 is created. Another object for 20 is created. B now points to this new object. A is still 10. It's like this, it's like you have one label to one object. I stick one more label to it. Then change your mind and peeled off that label from that object and stuck it to another object. That's what happened. Trying it? Clear with this? Know this concept. This is not just the case. This with simple assignment. This is a definition statement. This statement defines a variable which points to an object. Correct? All definitions create a new variable or recycle a variable pointing to an object. When I say def, what does def do? Define a function. Am I correct? If I say def square of x, for example, and here I'll say maybe a function body that says return x into x. You might think this is a function definition. Python sees it no different. Even here, it creates a variable called square. Creates a variable called square that refers to a function object. A function object, an object of type function, a class function you can say. And this function object represents this body that says return the bytecode of it, x into x. When you call square open close parenthesis is an operator, it actually calls a method on this function. Every operator will map to some special method on a function object, in this object, right? So it calls this method. Whatever argument you give, the argument is passed as x and is evaluated and gives you return. So I should tell you the function is also first class object. I'll demonstrate that right here. One example I'll show you. Suppose if we just say def square of x, return x into x, alright? We just specify r is equal to square of 2. Print of r. You know what you get? You'll get 4. Am I correct? So I'll run this. You can see the result. You can see the value 4 is printed. Value 4 is printed. I just got this to be executed, so it printed this. Alright? So next. Suppose if I just say r is equal to square. As r is equal to square, what exactly happens? Yes, it's a reference assignment. Now I say print r, just see what's the result. And I run this. Look at the console. Function square at something. Print will always ask string representation of an object. It's a print of any object, right? Any reference, whatever object reference points to. It asks the object as a string, what are you? Some objects will show a string as numbers will show that numbers in string. Function object will say I am a function, so and so function at so and so address or ID, object ID, right? So it shows here. Now suppose if I just say print r of 2. You know what I'm trying to say over here? So you see this? It's very difficult to do something like this in most statically typed languages. Functions are treated as first class citizens in Python. First class citizen? What do you mean by that? In Java, C, C++, functions or methods are treated as second class citizen. You know what it means? You cannot assign it to a variable as it is. When you do something like that, you create some hacks. In C, you use function pointers. Function pointers, special hack. Right? Or functors and so on in C++. In Java, you have to create an anonymous inner class based on interface and so on. You can't have a method outside a class.
In Java, we can pass functions as arguments inside the variables.
Lambda expression. That's an anonymous function. That's not a proper function. It's a lambda object. It's called as. It's a workaround. The Java ID is brought out. What Python disposed of, Java is taking it. In Python, lambda expressions are treated as bad things. They're thrown off. They're garbaged. Languages Scala and Java now saying, oh wow, lambda expression, let's use it. Why? Python's got better ways to solve problems than using lambda expressions. I'll discuss that later. Talk about map expressions. Okay? But anyways, now I told you that just not just functions, even classes are first class objects. I'll show you another example. As a class, employee, right? And maybe don't worry about the implementation and so on. Maybe employee has a method called greet of s and say I can just specify hello world. When I say print of employee, employee is a class object. We can see this. Run this now. The Python console, it says class in main module employee. It's a class. It's a class object. I could say staff is equal to employee. You know what I did? How do you instantiate an object? I assign employee to staff. Whether you say E is equal to employee or S is equal to staff, it looks like two different classes, am I correct? No, they are aliases to the same class. Print E and S. And you can see them. Both of them are seen as employee object. Right? This employee itself is a variable. When it's a class name is a variable. And that refers to an object called class object. When I define a function name is a variable. That refers to an object created called as a function object. Right? Not just that. Even if you know about modules. How do you load a module? You say import and module name, am I correct? You say import OS, for example. Or import sys, more simpler. Import sys. Very commonly used module. System, right? When I say print of sys, just see what you get. Module sys. Perfectly fine to say A is equal to sys. Print A dot version. It's like telling sys dot version. Because modules, functions, classes are first class objects, and all of these are nothing but definitions. You can define them inside a function if you want to. You can return something, right? So Python aims to be more orthogonal, more consistent by its nature, by its design, right? In fact, some of the interesting traits that I can tell you, unlearning habits from C++, Java is this. Suppose in C and C++, Java folks, what they do is write a Python program. I see a lot of people write Python program like this, a large application in Python. The first 20 lines will be only import keywords. I'll tell you that's a bad design. That's a bad practice. I'm loading different modules, right? I load all the modules in the beginning. Then use them somewhere. Maybe there's one function that uses a module. No other function uses it. Let's assume there's a function called, let's say, def print date, like I showed in the PyShell example. This print date wants to print the current date. To get the current date in string format, the easiest way to get it is time.ctime. So I'll say from, or I can say import time, print time.ctime. Alright? I'll say print underscore date. See the result? Oh, I didn't, did I run this? No, I didn't run this, I think. I'm going to save this file as local import. Let's say 5. I don't have 6. Yeah, can you see this? Current date. What you see here is that I did not import a module outside a function. Where did I import? Inside a function. So if you define a variable inside a function, what happens to that variable? That's a local variable. Now this time, right, is a variable local to this function. So the reference to the module is only there inside the function. Outside this function, you try to say print time.ctime. It may not work. You'll get an error. You see that? Print side of time.ctime. Name time is not defined. Local imports are pretty common in Python. If you believe a couple of modules or a couple of module members used by just one or two functions, it's safer to just import that module inside the function itself rather than putting it in the global definition. Right? This makes your program more maintainable, more lightweight. Do you this? Yeah. Yeah.
See, when I'm writing this code in a large scale application, I feel that this will be a local import. I can use it as a local import.
Yes.
So today I write it like that. Tomorrow, again someone has to modify the code and use the same import time in some other function.
Yes.
So doesn't he have to unnecessarily go and change my function
No.
and take this import, place it at the top so that it can be used globally?
Not required. You can safely say import time in this function also. And this module will not be loaded twice. Modules are loaded only once. As import time, you only create a variable referring to the module object. The module is not loaded, it's loaded. The module is already loaded, you just create one more reference to the module object. That's it. It's perfectly okay to do this. Only thing is that if at all there are 4 functions which are sharing a common module, trying to put all those functions together in a common .py file, put that module import in the beginning and then share. Refactoring must be done. In such case, the refactoring, you will think that you are refactored. Now you have 4 functions which are there across 2 different modules, 2 or 3 locations. And all those 4 modules are sharing some common libraries. These are members that deserve to be in the same module. This will allow you to refactor it, redesign your thinking. Clear? So it's a concept you know. What I'm trying to say is that all of these are treated as first class object. That means you can define a class inside a function, you can load a module inside a function, you can define a function inside function. Or define a function inside function, you can do something like this. I'll right away show you one of the interesting design patterns here. I'll say def by of I'll just say I'll just specify amount. Okay, what are the amount I have? If amount is less than 1000, def toy, print this is a toy. And if amount is less than maybe 10,000, def expensive toy. This is an expensive toy. If amount is less than maybe 1 lakh, print bike. If you closely observe, I defined a function called by, which takes an argument. Based on the argument that I pass, which is assuming it's a number, different functions are being defined dynamically. Let's just say this. When I say A is equal to by of 100, print A. What do I get? I'll just say, okay, I'll just say function run this. Do you see over here? Some toy. Like in fact, I can call this. I can say print, or I can just simply say A open close parenthesis. That's enough. I'll close this file. I think I'll save this as run this. This is a toy. Suppose you give the amount as maybe I'll just say 6,000, right? Run this. It's an expensive toy. Suppose if I just say 60,000, right? You bought a bike. What you see here is that here's a function that creates a function, another function dynamically and returns it as per the parameters. This is a design pattern. You know what this design pattern is called as? It's a factory method. It's a factory method. It's a function factory. A function is manufactured based on specifications. And each function will work differently, right? Each function will work differently. Here I give very silly functions. Think about a real world scenario. If I just say db connect, create a function or db connect of a string oracle colon slash something, create an oracle connection object, right? If I say MySQL colon slash, create a MySQL connection object. So you can do this kind of things dynamically. That is, you can define a function dynamically inside a function based on a criteria. Because function definitions are also mere definitions, all in runtime. Clear with this? Right? Maybe if you transform this to a class, this could be a class factory or object factory, right? So you can implement factory methods pretty easily. So I told you about everything being an object in Python. The next, one more fact you should know about Python is all assignments, okay, all objects identified by references. There are no copy by value or assign by value ever in Python. The confusion is not there.
So I left my charger there.
I think it's here.
Thank you, sir.
So I told you that in Python, right? There's something called copy by value, pass by value, assign by value. Shiny. Pass by value, copy by as per C program. Right? Everything is the lingua franca of communication, only references. Objects are created, you're passing an object to a function, the reference to an object is passed to a function. The function is returning a value, it's not returning a value, returning a reference to a value, reference to an object. If you're assigning something to a variable, you're assigning the reference to an object to a variable. All assignments are assigned as references. Right? So in the context, so I can talk about this. So it's variables within a namespace or function, that's a reference. Attributes of an object also a reference. Items of a collection also references. Actually, there are three kinds of reference in Python. Just three types of references. There are three ways to refer to object, I would say. One, creating variables. Example of it, like when I define a function, define a class, or I use any assignment statement, I'm creating variables. Right? Just show you this. Let's just say name is equal to John. His name is a variable, right? This is a variable assignment. So def greet print when this is a variable assignment. So all these are variable assignments. Even when I say class name like this, or if I say import sys, or say from sys or from OS import get CWD, right? So basically what happens is to all these are variable assignments. To maybe give a more summarize information, creates a variable reference name to John, an object called John. This, what does it do? This creates a variable reference square to, greet to a newly created function object. When this is the same story, we just say creates a variable reference car to a newly created class object. Class are also objects. What about this? This creates a variable reference sys to sys module. What about this one? Creates a variable reference get CWD. Get CWD is a variable referring to says can say OS modules get CWD function. Technically, all of these are variables. All of these are variables. Now, all of these are variable assignments. So, what is the next thing? We just say attributes. What are attributes? All attributes will have a prefix of dot. For example, if I just specify import sys, this creates a variable, no doubt. But when I say print sys dot version, right? In this case, version is an attribute of sys module object. Typical objects attributes. When I say this is a marker, then I say marker dot color of this particular marker, attribute of this marker. This marker dot price, this marker dot owner. So attributes of this marker I'm trying to represent. They specialize to an object, right? So now this called as an attribute. In fact, you can do something very interesting. You can just say sys dot version is equal to this. In fact, is called as a get ATTR. Get attribute. When I say object or attribute as right hand side expression, I'm getting the attribute of an object. But if I say sys.version is equal to 4.0, this is called a set attribute. This is not really an assignment. This is called a set attribute statement. This assignment is treated as set attribute statement. Okay. I can print this. I can just say vars attrs items. I can say print sys dot version yet again. If I just try to run this. Oh, hang on. Did I put some where comments? Oh, I put attribute over here. Oh, sorry. I'll rerun this. Rerun this cell. Can you see this? First, the version showed up as 3.63. After, when I try to when I say sys.version is equal to 4.0 and I say sys.version, it's printing 4.0. Right? This is nothing but attribute assignment. This is called as attribute assignment, or also shortly called as set ITTR. Set attributes. This is a get attribute operation. This also is a get attribute operation. Right? This version is a reference to a string object, but the version is not a variable, it's an attribute of sys module. Assign it. Attributes are also references. Clear? The next thing I should also tell you is, suppose we say A is equal to John Smith. Right? If I say this A is a variable, but if I say print A of 0, what do I get? John, right? Everybody knows this. So you can just run this. When I run this, you get an output called John. You know what I did here? The 0 is an index of a list. The index of a list is a reference to a string called John. Right? Reference to a string called John. I tell you that a list, dictionary, tuple. These commonly used collections. They're all collections of references. Those collections don't store values. They store references to values. Think of array of pointers. Array of pointers, similar to that. They're all like, collections of references. So when you say A of 0, the 0 happens to be a slot in a list which stores the address of a string object that holds John. Right? This is also called as a get item operation. Getting an item. Suppose we say A of 0 is equal to Adam. This is called as set item operation. This is also called as item assignment, or also called as set item. So if we just again say print A of 0, you can see this. Oh, I think I should run this cell. Sorry, select this cell. Execute it. Can you see the result now? John, Adam. So I tell you that all of these are examples of references. References can be variables, right, which are created by myriads of ways. It could be attributes of an object. Attributes of an object. It could also be an item of an indexable collection. Item of indexable. Even if I say dictionary of key, right, that key will act as a reference to a value. Through a key, you get a reference to a value. Right? So all of these are three forms of references that are available in Python. So identifiers identify objects just like labels on real world objects. I think I told you this. And then all assignments work by copying references. All expressions that result in an object will return the object reference. That is right hand side if you have an A expression which results in some value. The value is nothing but an object ultimately. All values are wrapped in some object. The object reference is what is returned, not object by itself, right? And all arguments passed to functions are done by copying references. To prove this, I'll show you another example. Suppose as I say def, and I can just specify, uppercase of n, right? I'll say, okay, I'll just specify, not uppercase, I'll just specify, n of 0 is equal to n of 0 dot upper. I say A is equal to John Smith. Print of A. Okay, that's a upcase of A. Print of A. See the result? John Smith was like this. Later on you can see John became uppercase. What do you mean by this? It's basically this. When I said upcase of A, this A is there, right? Passing as an argument. What am I passing? Reference to this list. Because the reference to this list is now available as n. N of 0 is equal to n of 0 dot upper. Means I'm trying to convert it to uppercase at least to. Now what am I doing? Mutating the list. It's a proof that all arguments are passed by copying references. Clear with this? There's no copy by value or pass by value in Python. Clear? Any questions? Doubts so far with this? Alright, so coming back, I think I told you about these particular facts. Then by now we should have known that all definitions in Python happen purely in runtime. All variables are created in runtime. All objects are created in runtime. There is never something called compile time resolution ever in Python. Right? So when I say identifiers, variables, attributes, and items are created and defined in runtime. Until a statement is evaluated, variables are not defined. Say A is equal to 10, assume that statement. Before that statement, the variable A is not there. After statement, A comes to exist. A comes to existence, right? So if I even try to delete this variable A, it's deleted in runtime. Clear? So all objects are created in runtime. All the class definitions create class objects in runtime. Function objects also created in runtime. Even importing modules, module objects could be created in runtime if they're not already loaded. Okay? This effectively makes Python a fully dynamic programming language. Python is 100% object oriented, 100% dynamic. Everything is dynamic in Python. All variables are created dynamically, classes are loaded dynamically, modules are loaded dynamically. Right? Everything is dynamic. There's no static definitions ever in Python. Assign it. Clear? So you can see the next fact is tell you that an object with no reference is subject to automatic garbage collection. What do you mean by that? I think if you come from C++ background, you allocate memory on heap, you have to free it. Right? In C++, you know that destructor operator. You need to use that explicitly. If you move on to modern language like Java, they come with automatic garbage collection. Python also has one. In Python, any object which has no more references to it is automatically marked for garbage collection. Right? You can explicitly get rid of variables by using del statement. Del can be used to delete a reference. For example, I can say this. Remember, so many variables are created here. So many variables are created here. So if I just say print name, greet, right, car, sys, get CWD. So all of these are variables technically. All of these are variables and the variables values are printed when I run them. So when I run them in the console, see, John, function greet, class main.car, module sys. Then you can see built-in function get CWD. So something, right? Now suppose if I just say del car, print of car. Let's see what happens. Name car is not defined. What do you mean by that? Whenever you try to say del car, what does it do? It deletes the variable. Remember, it does not delete the object, it deletes the variable. Object might get garbage collected if there are no more references to it. I'm saying it. Something you should know about the O features over here. So del will explicitly delete a reference. It can be a variable. You can also delete elements of a list. How do you delete elements of a list? Remember this two list over here, two element list. What if I say over here del n of 1, delete index 1, right? Now to this, try running it. See the result. See, the list only has John. Delete can be used to delete any reference. It can be index of a mutable collection, right? It could be del dictionary of key, del list of index, both are mutable objects, right? You can do that. You could say even something more exotic like this, though it's not a wise idea. You could actually say del sys.version. If I now say print sys.version, see what you get. Attribute error. Module says has no attribute version. I got a module. the model comes with a lot of baggage, a lot of functions, a lot of attributes. Some attributes I don't want, so I remove it. This is actually called monkey patching. I can remove attributes that I don't really want to use and only keep that lean object if I want to. Right? This is also possible. Yes, it is. Clear? So delete can be used to explicitly delete a reference. Okay? A reference could be an attribute, it could be an item of a mutable collection or a variable indeed. Clear? So identifiers are also disposed of automatically if there are local variables defined within a function and the function returns, thus exiting the scope of the function body. All local variables will only remain as long as the function is in existence. When the function finishes execution, all the local variables are disposed of, thereby reducing the reference count to the object they refer to. So object can get garbage collected, the reference count becomes 0. They become candidate for garbage collection. Okay, they are freed automatically. So variables, attributes, and items are not exactly the same. The biggest unlearning that you need to do if you come from C++, Java background is that attributes and variables are not the same in Python. Variables are not attributes, attributes are not variables. I'm going to demonstrate that example. Let's say A is equal to 100. Okay, I'll define a function called foo. In foo, I'll say in foo A is equal to A. Right? Yeah, I'll call foo function out here. What will be the output? Yeah? Info A is equal to 100. Correct? Most languages, same story here. Info A is equal to 100. Whenever you define any variable outside a function or outside a class, any variable definitions are all global variables. All variables defined outside a function body and outside a class body are local variables. Clear? Sorry, global variables, not local. Global variable. This is a global variable. Now suppose I go here, I will just say A is equal to 100, A is equal to 200. What am I doing? In foo function, I am redefining A as 200. In the main program I will say A is equal to A. What is the result now? Yes? 100, 100? 100, 200. 100, 100. One of you or two of you are saying 100, 200. 200, 100. Wow. You come from JavaScript background? Such things such magic will happen only in JavaScript. It will be 200, 200, not even 200, 100. Okay, I'll run this and show you. Surprise. Unbound local variable, unbound local error. Local variable A referenced before assignment. You know where the error is? The print statement. All definitions inside a function will always create a local variable. If you define A is equal to 200, it does not really care whether the A is a global variable or not. It creates a local variable. Now the problem is, you're trying to access this variable before definition. That's what the error is. You cannot have mixed scoping in Python. For a while, access global variable. From now on, look up local variable. Such things don't happen in Python. So look at scope, either the global scope or the local scope inside a function body. So if you replace the statement, if I...
But if this is at runtime, then it should access the first print statement.
Python is not a line-by-line interpreter. Python is a compiled interpreted language. What do you mean by compiled interpreted? The program is compiled into a bytecode and then the bytecode is interpreted. During compilation, the function body, right? The function body is getting compiled to bytecode. It creates a local. The problem is you're trying to access a local variable before definition in runtime. That's what the error is. So prove that Python is a compiled interpreted language, not like Tcl and Shell, where it's a line-by-line interpretation. Getting what I say? Now if I just switch the statements, now it will work. Now what do you think would be the result?
200,
100, 100? 200, 100. Good. Inside a function, the lifespan of the variable is only within the function. It sees a value 200. The function exits, the global variable is what you can see. What you know now is you cannot modify a global variable directly from within a function. You cannot modify global variable directly from within a function. If you really want to modify a global variable from inside a function, you should say so explicitly. It follows Zen rules of Python. Explicit is better than implicit, right? So if at all I want to modify this variable to 200, what you should ideally do is, you should actually say here, this case, right, global A. This is actually a compile time directive. When the code is getting compiled, you're trying to tell the Python compile time, don't create A as a local variable, but use a global variable. The code is compiled likewise. I run this. You can see. Understanding it? Rules of scope. Remember, there's global scope, local scope. Never a mixture of both. Either you can only access the global variable and modify them, or access only the local variable and modify them.
So we cannot put the global after print.
No. It's considered syntax error in Python 3. In Python 2, you'll get a syntax warning. Python 3 is considered a syntax error. Should not do that. So if at all you want to access global variable, the right recommendation is put this global keyword right in the beginning of the function body. Never after any other statements. The directives. Clear? Understanding it? Very understood? Alright. Let me test your confidence now. Color is equal to red. Class car. Color is equal to blue. Def init. For those of you who did little bit of object orientation Python, will definitely come across what init is. A method that's called during instantiation of an object. Here I'll say color is equal to green. Def drive. More about what they self and everything after break. But for now, trying to only focus on scope. Okay? Print. Driving a color car. C is equal to car. C dot drive. Run this. Tell me, what color car will I be driving? Yes? Error? No, I don't think there's an error.
Blue color. Green.
Blue color.
Blue.
How many are for blue? How many are for green? Okay, everybody said blue, so I'll say green. How many vote for red? No votes for red? No votes for red? Surprise. No one important rule. This is a local variable. This variable is only visible inside init. Init is a function technically, right? When init exits, this variable is disposed of. So green is never in the picture. This is a class attribute. You know what happens? All definitions inside a class body creates class attribute. An attribute does not participate in scope resolution. It's a big unlearning that you do in C++ and Java if you come from that particular language. Scope resolution is only applicable to variables, not attributes. So in this case, when I say def drive self, let's say print driving a color car, it checks whether color is a local variable. You said color defined in drive, it's not defined in drive. Then you check for global color, global variable. If you really want to access attribute, attributes must be accessed explicitly with the attribute resolution operator dot. You need the dot operator. Without dot operator, you cannot see attributes. Again, applying the rule in Python, explicit is better than implicit. So if you want to really print the value blue, you should say car.color is equal to. This is how we access class attributes. Right? Know the difference. In language like Java and all, Java and C++, when you look at a name as it is, you have to see where it is declared. It's declared inside the class, declared with the static keyword inside the class, declared outside the class if it's C++. Right? Here there's no declaration, there's only definition. So the only way to access attributes is with the dot operator. If you only say color, it's got to be a variable. It is never an attribute of something. Understanding it? The only confusion is when you're defining attributes inside car, you don't have to put that car dot color here. It's understood. When you say color is equal to blue, all assignments or all definitions inside a class creates class attribute. Remember this. I'll explain what does do, but I'll show you something. If I say self dot color, what will be the value?
In line number 10,
Line number 10, okay?
color is not defined, right? Anywhere inside, right? So how
It's
is
defined
it
here, right?
global
It's defined here. Defined there, right?
That is not inside, right? Last time inside foo it was not defined. A was not defined inside foo. It was outside.
Am I able to access it inside? Am I able to access it inside? Remember what I showed the first? Let me retract a bit. I need to do a lot of undos over here. Let me go back. Yes. What's the result of this? Error?
Error,
This was an error? Was this an error? Read again. Was this an error?
then why did error? When you define it again, error.
Yes. Because there is no definition of A inside a function, this A resolves as global variable. If you define A inside a function, this is a local variable. Local variable will always mask off the global definition.
So basically what you are saying is in Python, it won't go one level upward, it directly goes to global.
What is one level up here? There's no one level up here.
I mean like in class, right? In class we have function. When it is looking for color, it is not looking the color.
This is not a variable in the first place. It's no difference.
Again, no.
It's an attribute. If this was a variable, then the story is something. This is not a variable. What did I tell you? All definitions inside a function creates local variable. All definitions inside a class will create a class attribute, never a variable.
Previous
stop.
one when the error was there.
Which one?
Previous example, there was error.
Yeah. The error was not because of this. You know what the error was? Because of this.
But how it
Accessing a variable before definition will always cause an error. Accessing a variable before definition will always cause an error.
It will take the fifth line consider when it will interpret.
Again, I should reiterate. It is not line by line interpreted. Compiled. During compile time, it said if you look for a variable A, look for the local definition. Understand it? By the compile time, I actually meant this is a locally scoped variable. Scope resolution is resolved during compile time. In this case, the compiler will rewire it. So, no one looking for a variable before definition, that's a problem. You can take the remote and you need to keep turning it off every 10 milliseconds. They'll automatically turn off. Even here also turn it off. It's cold. I have my safety jerkin on, so it's okay. Right. Clear with this? Know this scope resolution and the difference between variable and attribute very well. You don't know this, you don't know object orientation Python. The core foundation of object orientation relies on your knowledge about scope, knowledge about the difference between a variable and an attribute. Most people who come from C++, Java will see both of them identical. In fact, C++ they use this kind of confusing name, member variable. There's nothing called member variable here. There's nothing called instance variable over here. You don't use the word instance variable. It's considered wrong grammar in Python. You say instance attributes, class attributes. Attributes are attributes, variables are variables. Never mix them. The only common relation between them both, they both are references to objects. They both are reference to objects. Clear? So coming back to the summary, I think I told you. Variables, attributes, items are not the same. Variables have scope of visibility. Global scope, local scope. There's another scope called nested static scope, which I'll discuss later on. Okay? So this is later on. Attributes do not have scope and are always visible. That is, are public. If I get an attribute to a class or any object, it's always visible. There's nothing called private attributes. Privacy is only by convention. In Python, privacy of attributes is only by convention. Encapsulation is only a conventional mechanism. There's nothing like controlled, or you can say hard-coded private members, which you see in other languages, right? So you can see over here, and must be accessed explicitly using the dot specifier following the attribute, method, relation, order rules. To understand what is attribute, method, the dot is an operator. You know that attribute is sys.version. There is no guarantee that version belongs to sys module. Version could either belong to sys module or could be inherited from his parent. So it's something called attribute resolution rules or method resolution order rules. It'll apply that when you use a dot operator. I talk about inheritance after break. I'll tell you more about that. Right? Items of a collection are not technically identifiers. When I say A of 0, 0 is not an identifier. 0 is an actual value. But the value will be mapped to a reference based on the data structure. And from the reference, you will actually get a value. Right? So you can see, though they may represent reference to objects from within a collection that they belong to. Clear with this? There are some very basic things you know. Okay, we'll get back after break. After break, I'll tell you about some more interesting facts. You'll learn after break that there are nothing called variables. Everything is an attribute. We'll discuss after break. And then I'll tell you there's nothing called attributes. Everything is an item. Okay, so those things you know. Okay, we'll come back after break.